All right, guys, so we're going to do a bit of a word problem here and then give you a chance to work through some more of them. But before we do anything, of course, we're going to start with our bell work, which just takes us back to last class and redo that. So if you haven't done it already, then please just pause the video, take a moment and do it. And if you've already done it, then stay tuned for the answer, and we'll take a look at it right now. So as we go through this, if we want to find dA dr, that means we're taking the derivative with respect to r. That means that this part is pretty easy. It's just a prime. And over here, we're going to get 8 pi r. And when we're doing that, what we need to do now is figure out, okay, there's our derivative, but we need to find it at the exact moment that the radius is 3. So this would mean that a prime is going to be equal to 8 pi, and instead of the radius, we're going to say 3. And so we will get that it's going to be 24 pi. Now, we should also put our units in there, so centimeters squared, and that is going to end up being what we get, so 24 pi centimeters squared. Now let's take a look and apply some of these things to a word problem and kind of go from there. So we've got a rectangular sheet of cardboard. It's 15 inches wide and 24 inches high. Squares with the sides of length x are cut out of each corner, and the 4 resulting tabs are followed up to make a rectangular box. No top on the box. Find the value of x, which gives the box the largest volume. So just like our steps here, first thing is to draw a picture. So I'm going to draw a picture of my sheet of paper, make it somewhat rectangular looking. It tells me that the height is 24 and the width is 15. It also then tells me that I want to cut some squares, maybe actually not do them dotted, out of here where the dimensions of those are x by x, and then they're going to be folded up. Now what that means is that this is no longer going to be 15, it's going to be 15 minus 2 x's, one for each side that was cut out. And this will be 24 minus 2x as well. So the next thing is we need to make sure that we can find a formula, right, that relates all of these things. And so what we want to do then is find v, that's our thing to be maximized as well. And that's going to be equal to our length times our width times our height for a rectangular prism. So now I can take this and I can plug in the things that I know. My length, let's call that the width, is 15 minus 2x. And I know that my, I guess maybe that should have been the, well, whatever, length, width. The width now is going to be this one, 24 minus 2x. And I know that the height of this thing, now that we've turned it into a box, is going to be x, because when we fold these things up, the height of it will be whatever x was. So before I can do this, I mean, that's not true. I could do product rule on this. Absolutely could. I can also not do product rule on it. So let's do product rule, but keep in mind that if you're having a hard time with that, then you don't need to. What I will do to make it a little bit easier is I'm going to put that in first. And so that's going to give me 24x minus 2x squared, because it'll be a little bit easier if we don't have to do like two product rules. So now what I can do is I can take the derivative of this. And so that's where we do the derivative of the first, which is negative 2 times the second, plus the first one times the derivative of the second. And that's going to be our derivative. Now the truth is, that's actually pretty hard to deal with. And so it may actually be easier to not use product rule in this case, because if I want to now figure out how to make this a maximum, that means I need to make it equal to 0. Well, trying to solve this when it's equal to 0 is actually going to be really hard. So instead, we need to put all this together, which means that it might have been easier to put it together at the beginning. So I'm going to put it together first here, and that's going to give us negative 48x plus 4x squared, and I'm just putting that negative 2 in. Over here, I'm going to multiply these together, and 15 times 24 is going to be 360. 15 times negative 4 is going to be negative 60x. Negative 2 times 24 will be negative 48x, and then I'll get plus 8x squared. So then I can put all of these things together now. And so we'll start off with our x squared. So I'm going to get 12x squared. Let's see here. Minus 108 minus 156 x, and then plus 360. Now that's still pretty hard for us to factor and solve for x. So I'm going to pull out my common factor first, which is 12, and get x squared minus 13x plus 30. That's a whole lot easier because now I'm looking for something that's going to multiply to 30 and add to negative 13. Well, that's going to be negative 10 and negative 3. So I can factor this as x minus 10, x minus 3. That's really messy. Let me clean that up. And the whole reason I'm doing this is because now it's really easy to solve for when this thing is going to be equal to 0, because now that it's a bunch of things multiplied together, it's real easy for us to see that, oh, it's just going to be when this one's 10 or when that one's 3. So we now have our two answers. We should either cut out squares that are 10 by 10 or 3 by 3. But we need to check our domain, because the issue with this one is that if we take a look at this length, I'd get 15 minus 2 times 10. I would need to have a side length of negative 5. Well, that's impossible. So obviously, that's not going to be one of our answers. This one, on the other hand, will work, because I'll get 15 minus 2 times 3, which is going to be 9. So this one is possible, and so that's going to be what our answer is. Okay. And so let's see, how does it work? Find the value of x, which gives, okay, so the value of x in this particular case is simply going to be 3 inches. Or we could say squares of side length. 3 inches should be cut. And that's really it, guys. So we've now figured that out. Now you might say, like, how do we know for sure that that's a maximum? Well, there's a couple of things we could do. We could do a second derivative test. We haven't had time to look at that yet. So instead what we could do is do like a analysis to kind of prove it. But realistically, it's also like it has to be a maximum because it's not a minimum. The minimum, of course, is going to be if we don't cut anything out or cut so much that we get like something that's no longer an actual prism. But just in case you're curious, I will go ahead and prove it here real quick. So we're saying 3, right? So I'm going to go up here and just do a quick sign analysis there. So we got 3, so we'll pick 2 and 4 as our numbers, and I'm going to use this version of it right here. So if I plug in 2 into here, I'm going to get a negative here times a negative here, which is going to be a positive. So it's going to be increasing. And if I plug in 4, I'm going to get a negative, and then 4 minus 3 is a positive. Of course, that's negative overall, so it's decreasing, which proves that this is indeed a maximum with our sign analysis that we've done. So there you have it, guys. Other than that, there's a bunch more problems here that you can practice, and so I suggest that you give those a try.